to apply the second derivative test, we first need to find the second derivative. So f prime of x is 5x to the fourth minus 15x squared. And the second derivative then is 20x cubed minus 30x. Okay, so if we set this equal to 0, now we need to find our critical points from the first derivative, if the first derivative is equal to 0. So to find those, we want to factor this. So how about 5x squared, which would leave us with x squared minus 3. So our critical points are x equals 0 and plus or minus the square root of 3. These are the points we are going to test in the second derivative. All right, so f double prime of 0 is equal to 0. So this is inconclusive. Does not tell us what happens at 0. The second derivative at negative square root of 3 is approximately negative 51.96. Okay, so this is less than 0. Because that's less than 0, that means there is a maximum, a local max at x equals negative square root of 3. All right, the second derivative evaluated at square root of 3 is approximately positive 51.96, so that is greater than 0, which means we have a local minimum at x equals the square root of 3. Now, this does not tell us what happens at 0. So let's fall back on our first derivative test. First derivative test. All right, so I have my critical point 0, negative square root of 3, square root of 3. This should confirm what we know about those other two values. So the derivative is 0 at all of these points. Let's go ahead and leave those off for now. If we evaluate at a point greater than square root of 3, then it is positive. It is increasing. A point between 0 and square root of 3 is decreasing. So we have something like this. We have a local minimum at square root of 3, which we said. Between negative square root of 3 and 0, it is increasing. So we have a local maximum at x equals 0. And then past negative square root of 3, the function is decreasing, so we have a local minimum. And since that does not agree with the second derivative test, there must be a mistake here. And I think I see it. These two are switched. All right, so this function is increasing, and then it is decreasing past that. Okay, so there we have a local maximum at x equals negative square root of 3. And actually there is nothing happening here at 0. So there's not a local maximum or a local